Okay, welcome back, everyone. It's 2 p.m., so I guess we need to start. I hope you're all doing well. I'm glad you've made it to this session. Today's main overreaching topic for today's lecture is business intelligence or BI. Okay. If you can recall, last time we wrapped up, we finished which topic? What did we talk about for the last couple of weeks? We talked about decision support systems, right? And it's a broad topic. When people hear decision support system, they usually think of a software, like some kind of application. But again, as you can tell from our lecture, it's a broad topic that involves the technology itself, like software, data, algorithms, and also the so-called socio-technical perspective, all those psychological factors that come into play when people make decisions based on data. And we talked about some of those factors when we covered cognitive biases, the kind of biases or imperfections that humans have when they make decisions, even when using data or sophisticated computer tools. Okay, so that was decision support systems. Now we're moving to a new topic called business intelligence. Again, if you're joining us in Zoom, I'm assuming you can hear me. If you would like to interject, if you would like to say something or ask something or make a comment, if something is not working properly on your side, feel free to use your voice. No need to raise hand in Zoom, no need to type anything in chat. Just please use your voice to let me know what's going on with you guys, okay? Once in a while, I'm trying to turn my attention to my Zoom screen, but sometimes, I keep going on and on without paying attention to what's happening in the chat. So voice is the best option if you want to communicate with all of us. So, okay, so what I will do, I'll share our screen. So this is the module that we're continuing. So it has both decision support systems and BI as two main topics. So now we're moving to the BI topic, okay? These are my presentation slides. As usual, there's a video presentation based on those slides posted to YouTube. So if you want to listen to this lecture in a very condensed format, then you're welcome to use this YouTube playlist, especially when you're preparing for exams, okay? So I already downloaded my PowerPoint deck, so I'll open it here. A lot of the information in this presentation comes from the tutorial, and for some reason, we don't have it displayed properly on the screen. I think I'm blaming the projector. I think there's something wrong with the projector. But anyways, this is the reference. You should be able to see it on the screen. It comes from somebody named Hugh Watson, and he created this tutorial on business intelligence. But of course, I've updated that slide deck numerous times. So there are some more current examples. So it's not 100% overlap with this business intelligence tutorial. Now, a little bit of history. I would say decision support systems, DSS, our previous topic, became a very fashionable term somewhere in 1960s. You would imagine people would come on time in Zoom, but we always have late comers in Zoom, not face-to-face. I don't know why. Well, anyways, welcome if you just joined us. We're talking about business intelligence. This is our next topic. So in 1960s, decision support systems became a popular term. And I already told you that there was this great promise that computers, artificial intelligence will make our lives like heaven, right? Computers will make all the decisions. We'll just relax and watch computers do not only routine decisions, but also decisions involving highly ambiguous scenarios, unstructured data, and so forth, right? Unfortunately, this topic did not materialize. Personally, I explored a lot of decision support literature, myself, and I've noticed that starting approximately in 1970s, people started being skeptical about decision support systems and artificial intelligence. They basically saw that computers are not that great at making decisions for us, especially when it comes to unstructured, ambiguous decisions. I already told you that I saw that one book gave this example of chess. They were saying, well, computers can play chess a little bit, but they can never beat a grandmaster. They're also talking about the example of driving a car. They were saying, no matter how powerful a computer is, computers cannot drive cars, while humans can, regardless of their background, regardless of their educational level or intelligence level, they can drive a car, right? So in 1970s, it started losing its steam, I think, although it was still a hot research topic. And then by 1990s, something else replaced decision support systems. Somebody coined the term business intelligence. Okay? You see, technology field is also subject to fashion, just like any other field. I mean, when I say fashion, people usually think about clothing, right? You know, something that you wear, right? But fashion is also applicable to technology. A lot of people think that technology is something that is objective, that it's based on objective algorithms or data, but sometimes it's just a matter of fashion, right? So perhaps because of that fashion swing, that pendulum that swings back and forth, people go from one preference to another. Maybe because people lost some confidence in this whole research stream of decision support systems, the term business intelligence or BI became a more popular topic. Okay. Arguably, this term business intelligence, as usual, was coined in 1989 by somebody named Howard Dresner, who was an analyst at Gartner. I don't know whether you know those companies or not. There are two major IT research companies out there, at least in the United States. Number one is Gartner, you see the name right here, and number two is Forrester. Okay? Have you heard about Gartner and Forrester? Well, those are major IT market research companies. Most organizations, especially technology organizations, subscribe to their products. They do a lot of things. They do consulting. They do, I think they even do like some degree of implementation service, especially Gartner. I know they have a consulting arm, but their main business is research within the IT industry. So their main products are reports about the technology industry. So I would say most technology executives subscribe to those reports produced by Gartner and Forrester, and a lot of innovation. And one thing that Gartner does and Forrester does, what they do, they keep their they keep a tight grip on market trends, what's happening in the technology sector. For example, Gartner has the so-called technology hype curve, where they monitor which technologies are becoming popular, which one are losing popularity, right? So a lot of those popular technologies are kind of popularized and solidified by the research published by Gartner, right? So I'm not surprised that Gartner was the organization that is credited with coining the term business intelligence. By the way, I work for the second largest, which is Forrester. So my dissertation project was like a collaboration between Forrester Research and our university. So that's where I came in, and I worked with their sales team to create some tools that would support their marketing team when it comes to communicating value to clients. So basically, like on the technical level, I created a bunch of Excel dashboards. So Forrester is the second largest IT research company, their competitor of Gartner. So the term business intelligence or BI became very popular in the industry. When I first heard this term business intelligence, for some reason, I thought about corporate espionage, like spying on somebody, like digging out data. Well, it's something like that, but there's no like illegal connotation or confrontational connotation to it. It is about digging data, but only the data that is obtained through legal and ethical means. So by 1990s, I would say decision support systems, so DSS, became out of fashion, and the term BI was used to describe everything that DSS is, right? So all of those things that we discussed before, they are also applicable to the topic of business intelligence. It's just like a new, more fashionable buzzword. By the way, I didn't want to talk about it here because I don't think it's that important, but I think nowadays, well, actually for the last few years, I would say that business intelligence has lost, the term business intelligence has lost the popularity contest to another term, which is business analytics. So nowadays, everybody's saying business analytics instead of business intelligence, right? Now, I would like to emphasize this from the very beginning. When we say business intelligence, we're not just talking about applications, software applications. When we say business intelligence, we mean a very broad category of such things as applications, technologies, and also business processes, because it's also about, business intelligence is also about how you use applications and technologies, not just what those application technologies are. And business intelligence involves the use of applications, technologies, and process for what? Gathering, storing, accessing, and analyzing what? Data, information, knowledge for the ultimate purpose of helping business users make better decisions. When I say business users, I pretty much mean not just like for-profit businesses, but any organization, right? Running a non-profit organization is also a type of business, right? It's just a non-profit, it's a non-profit business, right? So it's also applicable to universities, to, I don't know, charities and things like that. So once again, business intelligence is a broad definition. It includes applications, technologies, and processes, not just applications and not just technologies. We're also talking about the human use, how humans use those applications and technologies within organizations. Another conceptual thing that is probably worth clarifying is that when we say business intelligence, we talk about not only getting data out, meaning analyzing data, but also getting data in, right? Sourcing data for a certain business intelligence platform, gathering, cleaning, organizing it, right? The reason we're clarifying this because some people say that business intelligence is about getting data out. It's largely about data analysis and not about getting data in. Because when you say some experts believe that getting data in is another field, which is called data warehousing, right? For sourcing, organizing, cleaning, and updating data. Some people even say that data warehousing is both getting data in and out. But in our lecture, we will say that business intelligence involves both getting data in and getting data out, meaning collection of data and analysis of data. So we're accepting that broad view on what business intelligence is. Some main targets of business intelligence. Again, remember I told you that business intelligence is not just an app, it's like a business trend, it's a business movement, right? So some of the main goals or targets of business intelligence movement is as follows. Number one, integration, the development of a single or few related BI applications. So basically, ideally, a viable, effective BI platform should be based on one single database, so one single platform. Okay. Now, the opposite of that would be having silos, meaning different applications, different databases scattered out across the organization. Okay. Now, why do you think it may be beneficial to consolidate all those applications, all those databases into one platform, as opposed to giving every organizational unit, every department the right to choose what exactly they want to use? Why do you think consolidation makes sense, at least to some organizations? What would you say? So for example, my former university, when I joined them, they had a bunch of applications to run different departments, like a CRM for marketing department. Then they had the system, I think it was called Logos it wasn't Coursera, it was like basically a learning management system, right? And each application was separate. There was a separate database. There was a separate unit using it. But eventually, they integrated everything using PeopleSoft. So PeopleSoft became one single platform on the top of which everything else was done, right, and built. So why do you think some organizations benefit from integrating all those apps, all those databases together? Any ideas in Zoom? Tucker. I think you told me you don't mind being.
What's that?
So why do you think some organizations benefit from integrating their data and applications into one single platform, as opposed to keeping them separate, like separate applications for separate departments?
Because it's all in one place.
So what's the benefit of having everything in one place? Okay, I'll give you one idea. Sometimes it's easier to manage a centralized system as opposed to going to different departments and maintaining different applications. What else? Go ahead, Ahmed. Say it again, please. Well, I guess you may be right. I mean, that single platform can be optimized for access, right? So it will be faster to find data. What else, Harrison? Yeah, so it's easier to retrieve data because you know where it's located. It's all located in a centralized location. I'm sure there are many benefits. One other benefit, and to me, it's the most important benefit, is that you have single version of the truth, right? You have single version of organizational data. Now imagine if everybody is maintaining different records. By the way, I hate to be negative, but Murray State is actually puzzling to me in that way. They have so many apps scattered everywhere, and sometimes we reconcile our record. Like for example, when it comes to student admissions, graduate admission, I'm running my own records using an Excel sheet. Then the College of Business as a whole is running their records, and admissions is running records, right? So we have 3 records of admitted students, the ones that we admit. And naturally, there is a discrepancy in all those records, right? Because it's maintained by different people, it's not the same, right? So sometimes they would ask me to send my data and they will say, like, oh, it's different from what we have. Like, for example, average GMAT score of admitted students. It's different from what they are, right? And again, maybe I'm wrong. I mean, who knows? I'm just saying that it's different, right? It's a bit problematic when you have all those silos. So there's definitely a need to integrate everything together so there's one single version of the truth, right? Of what's the average GMAT score of applicants is. Infrastructure, building the right kind of infrastructure that supports current and future business intelligence needs. So any initiative starts with infrastructure. You cannot start from ground zero. That reminds me, I'll digress a little bit. I will just give you an example about infrastructure problem. In my former university, it was like years ago, they started pushing for e-learning, right? Let's be the first university to offer fully online programs in the Middle East, things like that. That was their conversation. And when we were discussing all those things, I was a part of that steering committee devoted to establishing e-learning, right? Well, at that time, we didn't have IT director at the university, right? So all those discussions were done without thinking about the overall IT infrastructure. So when the new IT director came, he said, look, guys, forget about e-learning for the next 2 years. Forget about it. Because before we get into e-learning, we need to first of all upgrade our IT infrastructure. Number one, our Wi-Fi bandwidth. And indeed, at that time, the Wi-Fi bandwidth was terrible. Whenever everybody comes to classes, and that happens usually in the morning when undergraduate students come in, or in the evening when graduate students come in, I could not access my email, for example, right? Because the network was too slow. Everybody was accessing it, right? So number one, let's improve our Wi-Fi bandwidth. And he did it fairly quickly. They got just like some kind of better subscription from their internet service provider. Number two, I mean, actually not number two, after that number one problem, which is network bandwidth, they solved a number of other smaller problems related to e-learning. For example, number of power outlets. If you're doing some kind of e-learning or hybrid learning in class, you need to have everybody with a laptop, right? If everybody's with a laptop, not only they all need to have access to Wi-Fi, they also need to have access to power outlets, right? So we had to remodel, reconfigure some of our rooms to make sure that any student has an opportunity to connect his or her laptop to a power outlet, right? The other thing that came up is the platform, the software that we'll be using for e-learning. I think by that time they already implemented Blackboard, so we're starting to use Blackboard. But the problem was training faculty and staff how to use Blackboard. So we had this faculty development center that started training people on how to use Blackboard. Eventually, we talked about buying a mobile version of Blackboard that never materialized. So what I'm trying to say that infrastructure needs to be built up first before you start implementing such initiatives as business intelligence or e-learning or whatever that is. And then organizational transformation. Again, sorry for being repetitive, but business intelligence is not just about installing apps or maintaining databases. The ultimate goal of business intelligence is to change how an organization operates and competes in the marketplace, to create a business impact, okay, to create a business impact. By the way, my former organization, they took this seriously. They basically positioned themselves as a data-driven organization. So whatever you do in that organization has to be based on data. For example, you couldn't just go to senior management and say, I need additional money for project X. You need to bring data to show, number one, that project X is necessary, and number two, to show what kind of ROI, what kind of payoff you're likely to get, right? You're likely to get from that investment, okay? So it has to be all based on no opinions, right? No rumors, everything has to be based on data. So organizational transformation, changing operations, making organizations more competitive is the ultimate goal or target of business intelligence. Now, there are some widely publicized examples of organizations achieving transformation, improving their competitiveness, improving their position and profitability. Like one of those examples is 3M. As you probably know, 3M stands for what? What's this acronym for? But you know the company 3M, right? If you go to Walmart or Lowe's, you'll see a lot of their products like glue, notes, pens, I mean, whatnot. It's a huge conglomerate that produces all kinds of products. Light bulbs, maybe some ventilation equipment. They produce a lot of things. I think 3M stands for something like Minnesota Mining and Manufacturing, which is not that relevant, right? Well, anyways, read about what 3M did. So I'll give you a couple of minutes to read that mini case. So what was the main problem at 3M that they addressed? How would you describe it in one sentence? Well, what you're saying is right, but it's an example of a bigger issue of lack of integration, right? Yeah, that's what Ahmed wanted. Lack of integration. By the way, 3M is an interesting company. It's a huge conglomerate. And this conglomerate is comprised of smaller business units responsible for separate products. For example, there's a division responsible for glue. There's a division responsible for office supplies and things like that, right? That was their philosophy. They thought that if they keep running this huge conglomerate as separate organizations, they'll be more flexible, more innovative, okay? Because they will give that power to innovate, to create new products to those smaller organizations that are closer to the market. Okay, something is in chat. Sorry. Yeah, Tucker says 1 second. Oh, that was an old message. Sorry about that. Yeah, so their problem was lack of integration and communication. So they decided to bring all those divisions closer, so they have a high degree of collaboration. So their salespeople have a higher degree of understanding what's happening across different units. By the way, right around that time, I met a person from 3M. He was actually a visitor to our department. He gave a presentation about all those integration initiatives at 3M, and his title at 3M was kind of interesting. His title was Chief Innovation Officer at 3M. Okay, so one thing that they did at 3M, they created a database of expertise. So for example, let's say you work at 3M and you need to talk to an engineer who knows something about, let's say, light bulbs, right? So you can go online and you can search the database for all those people with expertise in light bulbs, something like that, right? So that you can find expertise that you need for your own product creation. Another thing that they did, which I found interesting, they created a lot of free coffee shops across their office spaces. Because the idea was that collaboration, sometimes innovation and collaboration, cannot be controlled, cannot be managed. In other words, you cannot get people into a room and say, go ahead, collaborate and innovate. It just doesn't work that way, right? So what they started doing, they started giving free coffee to all of their employees. And while drinking coffee, the hope was that while consuming coffee, employees will talk to each other, share their ideas and so forth, right? By the way, this whole idea came about from a legend. The reason I'm saying legend, because I don't know whether it's true or not. I always take those stories with a grain of salt. Marketing departments or PR departments, they like to publicize those stories. There's this like legend at 3M that there were two struggling divisions at 3M. One was responsible for producing notes. So they produced a lot of paper notes and they couldn't sell them. They didn't know what to do with them. And the other department produced a lot of glue that was not very adhesive. So they didn't know how to sell it because it wasn't that sticky or adhesive, right? So one day, two engineers from those two units, they were drinking coffee together and they were complaining about life. So one was complaining about that glue, the other was complaining about notes. And then eventually idea came to their minds. Why don't we combine those two products together, notes and glue with low level of adhesion? So the resulting product was what? Yeah, post-it notes. So apparently this is how post-it notes were created by two departments collaborating across their own departmental lines, right? Creating this new idea. So I don't know how true it is, but that's how the legend goes. By the way, after listening to this presentation, it was like delivered to the College of Business at the University of Houston. They created a lounge for doctoral students, pretty much with the same idea. There would be like free coffee, and there's a fridges, like with some drinks, you can hang out there. But for some reason, it was a nice, I mean, it was a very nice lounge. I liked it. But for some reason, doctoral students did not hang out there that much. I remember we booked it for a couple of official events. And then somebody started cooking in that lounge, and they really make the walls and carpets stink with all that cooking. So people stopped going there altogether, right? Which again proves that collaboration does not happen on demand. Innovation, collaboration does not happen on demand, right? If you ever observe artists, like creative people, how a lot of people think that they're like a bunch of lazy bums because all they do, they sit all day in bars or coffee shops doing who knows what. But that's how you foster and nurture your innovative spirit, right? You cannot be innovative in the office. You just kind of hang out, you're almost bored, you talk to different people, and then maybe some new ideas for a new song or a new novel will come to your mind, right? Just by hanging out and talking to people. Again, people are different, but I'm not like that. I mean, I cannot be put in the office and say, okay, be creative, create new ideas. Sometimes I go like for a walk with my dog and I just come up with an idea and then kind of I write it down, right? But it's not like on demand. Now, another interesting example is Harrah's Entertainment. Harrah's Entertainment, they like to position themselves as entertainment companies, but basically we are talking about a casino company, right? That's what it is. And I think there's one even here in Illinois, right? If you cross the border from Paducah to Marion, I think there's a Harrah Entertainment Casino. I've never been there, but I think there is one. So look what they did with their data, with their organizational data. Just read this mini case. I'll give you a couple of minutes. So what was the problem at Harrah's initially in relation to data? It was kind of similar to 3M, right? So what was the problem? Well, they had multiple touch points with their customers. So Harrah, it's not just casino company. They do have casinos, but they also have hotels. They're also running events, right? So this is how they make money, through hotels, casinos, various events, okay? Now, unfortunately, those events, those units were run separately, and there was not a single view of a customer, because a lot of times a customer comes to Vegas to participate in some sort of event, right? And because he or she needs to participate in that event, they will also book hotel, right? And since they're in Vegas anyway, they will also gamble a little bit, right? So a customer will deal with the company at 3 touch points: hotel, event, and casino, right? So unfortunately, they didn't have that complete integration of data for customers across all those touch points. And that's what they did with their business intelligence initiative. They integrated all this data so they can see where customers are spending, right? And they use it to their own advantage. For example, if somebody is spending a lot of money in the casino, then they would give person some kind of discount, I don't know, at a restaurant, right? Or they'll give them a free ticket to an event, okay? I've been to Vegas a couple of times, I think, and it's really amazing to me, like how people lose their minds there. Like I once was there with a relative of mine, and he lost his mind because there was this casino serving huge hot dogs. Like each hot dog is like this size, right? And this hot dog, I forgot what the price was, but very little, like $3 or $5, right? So my uncle, he was raving like about this hot dog, how good it is. It's only $3. And to me, immediately to me, it occurred like, well, people are spending their hundreds, if not thousands of dollars, right? And all they get from this casino is a $3 hot dog, right? You see what I'm saying? So this hot dog is nothing in comparison to what other people are spending in those casinos, okay? So they probably figure out based on data, let's give them free hot dogs, right? They're spending $1,000 on average anyway, so why not give them $3 hot dog? Although that hot dog could actually cost $10, something like that, right? The other thing that people are amazed with is that, you know, I don't know, how many of you have been to Las Vegas? Maybe I'm just talking about obvious things. Well, one thing that is interesting about Las Vegas, if you're gambling there, they'll give you free drinks. So there's a lady that comes in like with a tray and says like, what would you like? And you can have anything that you want for free, right? Now, the trick is they only come to people who they see play a lot. They will not come to you if you're just kind of hanging out there. They will not give you a free drink, right? Now, you understand what the trick is, right? Again, you have a person who is spending, unfortunately, gambling hundreds, if not thousands of dollars away, and then they will give him a $1 beer for free or something like that. And when this person drinks this $1 beer, he will lose his consciousness a bit more, and he will play a bit more too, right? Because if he wasn't intoxicated, he would say like, what am I doing? I'll just go home and sleep or something like that, right? So So that's the kind of tricks they're playing. Again, it's all based on data. I mean, they're calculating like how much money is bringing, those clients are bringing, what we can do with that money. Like, I know that a lot of high rollers in Las Vegas, they get free hotel stays. They're not charged for hotels because they know that this person will lose, I don't know, $20,000. So why charge him, I don't know, $500 for 2 nights in the hotel, something like that, right? So that's what they're doing across, across all of the touch points with their customers. I will end this case with a political statement. I think gambling should be illegal. I mean, I don't understand like why drugs are illegal, but gambling is legal. I mean, to me, it's the same kind of addiction, right? A lot of people, some people can control themselves, and I think I fall into that category. I see like what the trick is. I don't fall for that, but some people cannot control themselves, and they ruin their lives by gambling, right? So why is it okay to ruin your life through gambling while it's illegal to ruin your life through drugs, for example, right? And then video games should be considered next because people are ruining their lives by playing video games all day long. Again, some people can use video games to relax, right? But other people get completely consumed by that. Now, another reason this Hara Entertainment case is very famous is that there was one person working at Hara's Entertainment at that time. He was a part of that business intelligence team, and his name is Tom Davenport. Tom Davenport is quite famous because he has been like one of those major driving forces behind business intelligence movements. Okay, he wrote a lot of books, and he's been writing those books since 1990s, talking about business intelligence, how it can improve organizational performance. One book that anybody involved in business analytics, business intelligence definitely needs to read is this one, Competing on Analytics. From what I remember, it was published in 2006, and it talks about Hara Entertainment's initiative because Tom Davenport, he was actually a business school professor. I forgot which school he was from. I think it was MIT. That's where he was based. And then he took a leave of absence or sabbatical for 1 year, and he went to work for Hara's Entertainment. And then he wrote this book, Competing on Analytics, and he started popularizing business intelligence across different industries and different organizations. It's not that I'm dropping names, but I actually met him 2 times in person because he was our guest speaker at the University of Houston's Information Systems Research Center, and I was assistant to the director. I was working there. So I actually met him 2 times. He was our guest speaker, I think, over the duration of like 5 or 6 years, 2 times. Okay, so enough with background information. So let's start talking about the specific components of business intelligence architecture. And by the way, this lecture will touch on all of those components, and we'll do a hands-on exercise starting Thursday involving one of those components, data integration. Okay, so this is how a typical generic business intelligence platform looks like. Those are the typical components. Number one, you have the data component. Okay. Data can come into a business intelligence platform from various sources. So those sources can be internal, they can be external. The data can come from different stakeholders. This data can come from customers. The data can come from, regulatory bodies. The data can come from sensors that are used, let's say, in the production process, such as RFID or radio frequency identification sources. So all this data comes from different sources in different formats. Okay, if data has such high level of diversity, it comes from different sources in different formats. What's the problem when it comes to using this data? What needs to be done before this data is usable? Any ideas? I'm giving you a hint by pointing my laser pointer here. So this data needs to be integrated, right? That's what you wanted to say? Okay. So this data needs to be integrated. It needs to be brought into a common format. A lot of steps, a lot of things that need to be done. Number one, data cleaning. It needs to be cleaned. The quality of data needs to be improved. Reformatting data, putting it in a consistent format. Also making sure that this data is properly connected. So using some kind of referential integrity models or links to show how those data pieces are related. So it's only after this data is properly cleaned and integrated, it's loaded into a central data warehouse. By data warehouse, we mean that central repository where an organization stores all of its data. Okay, and once its data is loaded into a data warehouse, it also has to be supplemented by metadata. Okay, Metadata, it's a portmanteau word. It consists of two words. One is meta and the other one is data. Now, the word meta, I've been meaning to look it up in the dictionary, but I forgot what exactly it means. But it's a Greek word that means something like about itself. Okay, so meta means like about itself, some kind of recursion, something like that, right? So metadata means what, based on the dictionary definition of meta? So what is metadata? It's data about data, right? So you have data, but you need to describe it, where this data came from, source, when this data was created, right? What kind of changes or updates were made to this data, right? So all those things are called metadata, describing the data that you're storing. If you don't have metadata, then you will quickly get lost, okay? I've been in many situations where sometimes I get a hold of a data set that I think is very useful, right? But then I run into two problems. Number one, I ran into data quality issues, cleaning, right? I need to clean a lot of data, which takes a lot of time. And once I clean it, I realize another thing. I cannot make sense of the data. I'm not quite sure what exactly is contained in the data, right? That reminds me, when I was working at Forrester, I came across a big data set. And I mean, I don't want to, it was like some confidential data set about their business, their operations. And this data set had 3,000 observations, 3,000 data points. And I thought it was a great data set. After I cleaned it, to my great disappointment, after I eliminated all the entries that obviously had quality problems, I came to a data set of around 200 or 300. That was a big disappointment, okay? And even with that smaller data set, I could not make sense of some of the values. Let me just give you one example. Sometimes data is about Disney, right? Disney, whatever that is, okay? And then I try to match the data with the corporate information about Disney available in well-publicized online databases such as Warts. It's a financial database run by Wharton Business School, okay? And what I see, it doesn't match. The data that they have in the data set does not match what the official record is. And then I realized what happened was they hired they outsourced their data collection to a market company in India, market research company in India. And they would make calls in the United States to collect the data. And you know what I realized? Sometimes they would call a Disney souvenir store, let's say in Orlando, Florida, right? And they will ask them questions about whatever they're collecting, right? And they would put them down as Disney. Well, you understand that a souvenir shop in Orlando is not the same as Disney Corporation, right? So that's the kind of confusion they had in this data set. And if I had made it, like I actually asked them about those definitions, and so what do you mean by, like, for example, I would ask them, what do you mean by Disney? Is it like Disney Corporation or like a branch? What is that, right? So they couldn't explain to me, and there were no notes. There was no metadata for me to understand what it actually meant, right? So to make this story short, this data set turned out to be a big disappointment. I still got something valuable out of it, but my hopes were very high, and then they became almost close to zero, to the point where I was thinking about abandoning this whole project. So once this data is loaded into a data warehouse and properly described, it can be subdivided into separate data marts. Now, this is why it's done. You don't want applications and end users to have access to the data warehouse directly, because the data warehouse is huge, okay? And most organizations, they don't have that kind of computing power to support real-time access to this vast collection of data, right? The access will be too slow for the entire organization if everybody tries to access it, okay? By the way, that's what happened to us when my former organization went to a single platform. It was PeopleSoft. Everybody started querying directly from the central PeopleSoft database. And I remember during add and drops period, the entire database was down. It took like 1 hour sometimes to run a query because everybody was querying central database, and that includes students, checking their registrations, whatever, faculty, checking their class rosters, administrators trying to figure out who is enrolling when, whether we need additional sections and things like that. So the entire database was down. So our database administrator, Steven, he came to us and he said, look, guys, that's what I'm going to do. I understand that in the College of Business, you need to have access to data. I'll create a data mart for you, which means a subset of the entire database relevant for the College of Business only, right? And he said, I will update the data mart at the end of every day. So every day you'll have new data there, but don't, and he reconfigured everything where all of our queries would go to this data mart and not directly to the central database, because the system was too slow. It wasn't able to accommodate all that real-time access, and it came down to a simple problem where students could not register for courses, and that kind of paralyzes the whole add and drop week, right? Because the system is too slow, nobody can add their courses. So that's why you have dependent data marts. The reason they're called dependent because they depend on the overall data warehouse, but nevertheless they're a subset. They're like a copy of one element of the data warehouse. So once those dependent data marts, so you can think of them as like separate databases are created, you have users, you have applications, you have various technologies working with that subset, with the data mart. And then to support that infrastructure, you have metadata processes. I already described them, describing data as you load it into your data warehouse, as you produce this data. Data quality processes, improving quality of data. By the way, in my former organization, we actually had to hire a person who had to create a separate position to ensure data quality. Not data quality of the entire organization. We were specifically interested in data quality related to our accreditation. Because accreditation is one of the most important things for an educational institution. If you lose your, well, forget about losing accreditation. If you have some kind of situation where your accreditation is endangered, it gives a big blow to the entire college or university. I don't know whether you've heard about UT Martin, like that scandal that they had a few years ago. Have you heard about UT Martin? You know what I'm talking about? But you know what UT Martin is, right? It's that school part of UT system in Martin, Tennessee, which is 1.5 hours from here. By the way, they didn't lose accreditation. It was they were put on probation by the accreditation bodies. I forgot what was the entire story, but something was lacking. They did not correct those deficiencies. So they were put on probation, and it created a huge blow to the university because everybody, UT Martin is about to get shut down. Well, they were not going to shut down, but that's kind of nervousness this announcement creates, right? So eventually they were able to renew their accreditation, so everything was fine. But I remember everybody was running away from UT Martin. They lost like 1,000 or 2,000 students, so they were like the same size as MSU approximately, but they lost like 1,000 or 2,000 students. And I even know that some faculty ran away from across the border and they got a job here because they thought that the entire university will collapse because of that, right? So because accreditation is so important, we hired an accreditation person who would actually look at the data and improve it, right? For example, go to the source and say, what did you mean by that? What do you mean by the data point, okay? And I remember the decision point when it happened. We had an accreditation visit and we asked a guy who worked in our institutional effectiveness to generate some reports. And the reports that he generated, they were just like mind blowing. I mean, they were obviously incorrect, right? And he was like, well, I ran the query. That's his attitude was, that's what the data says, right? It's not my problem, right? But I remember there was like one example. Our doctoral program was growing to the point we were running out of resources, but he built a graph where it was declining very sharply, which was like completely ridiculous, right? But it was based, all those graphs, they were based on the data of poor quality. And then we have data governance. I'm sorry, I cannot show it here. Yeah, governance processes right here. Governance processes in relation to data, in relation to business intelligence. Any organization should have clear rules. Who owns data, how this data is distributed, who has right to access it, who doesn't have right, how this data should be protected from a privacy standpoint, and so forth. In the absence of this data, in the absence of clear governance rules, meaning policies, it's hard to carry out any kind of business intelligence initiative, okay? That reminds me of one of my projects. What I was trying to do in my former university, I was trying to increase enrollment in graduate programs, right? And that's what I thought, that's the idea that I had. We had a corporate arm of our university. It was called Abu Dhabi University Knowledge Group. So they were like a training consulting company. So they would do a lot of corporate training to employees of various corporations. And when I asked the director of ADUKG about the number of clients that they had over the years, he told me they had like 4,000 trainees, 4,000 clients. And it kind of, to me, it turned out to be like a very lucrative idea to try to get a hold of those former clients, because I thought that most of those employees have a degree, like a bachelor's degree, because they're enrolled in those training courses. It means they're interested in education and in advancing their education. So I thought about contacting them about our graduate programs, okay? So the first thing I did, I went to the CIO, Chief Information Officer of ADUKG, because we run as separate units. And I told her, can you please give me that client data, right? So her first reaction was like, who the hell are you? Like, why are you asking for this sensitive data? Like, why do I need to give? So that was kind of her reaction. She was saying, I'm not going to give you anything, and then, eventually she told me like, well, if you need the data, then get approval from our CEO, because we had a separate CEO for that organization, right? So I went to the CEO. I got his approval, because she kind of told me we have governance rules that nobody outside of our organization is allowed to access our client data, right? So I got this approval, but then she started like giving me reasons why she cannot give it to me right now. She would say, like, "Well, come next week. I need to do this. I need to do that." Eventually, I realized that she didn't have the data. She did not maintain the data properly as an IT director, and she was afraid that my project will uncover all those deficiencies. So basically what I found out eventually, she didn't have a data set of 4,000 clients, right? It was like different Excel sheets, different databases, different records scattered around all kinds of computers and all kinds of servers, okay? I remember I got a data set, I think it was fairly large, like from one of the directors. He maintained his own record, speaking about single version of the truth. I think he had like something like 900 records there. I was like, oh, great, 900 is a great data set. And then we tried sending emails to that 900 people. I think out of that 900, approximately 30 or 40% bounced back saying such email address does not exist, okay? So, sorry, it was either a data error or it was, people changed their jobs and they had their corporate email. So the data set turned out to be very much useless. We didn't get much out of it at all. Okay, so who is to blame? Well, governance processes. There are no clear rules on how to store this data, and also problems with data quality. Right, there were no processes to make sure that information about former clients is of high quality. So we'll start talking about each of those elements in a bit more detail. We'll start with data integration. So let's talk about source systems. So a typical initiative, BI initiative, starts like that. There is an organizational pain, some kind of problem or an opportunity. Again, in my case, the problem and opportunity was to increase enrollment. So the pain leads to certain business requirements, business applications, and you need to find appropriate data giving those requirements and giving those business intelligence application. Again, for your business intelligence initiative, you may source data from a single source or from multiple sources, sometimes hundreds of sources. And by sources, we don't mean just people or databases. It can be systems like ERPs. It can be data from the web. For example, a lot of companies, they supplement their internal data with marketing data. I once came across such database when I lived in Houston, and I was surprised. This database was largely about zip code. So you enter zip code and you get demographics like in terms of purchasing, like how much purchasing power people have, what they're buying. And to my great surprise, what I realized, I lived in a very cheap neighborhood. So the two most popular items in my neighborhood were beer and lottery tickets, right? So that kind of got me thinking that it's poor people who are buying lottery tickets, not wealthy people, right? You can also have sensors like RFID, radio frequency identification sensors, machinery. So all kinds of data sources can contain the data set that you need for your own business intelligence initiative. Also, this data can come from different platforms, and connecting those platforms, getting data from one platform to another can be a big problem. And by the way, there are a lot of business opportunities there. Again, when I lived in Houston, we collaborated with a company that was like a friend of our department. The company was, and I think it's still around, it's called Shipcom Wireless. So their business was creating middleware that integrates platforms together. One of their chief flagship products was a software called Catamaran. And that Catamaran application would integrate an ERP system, SAP. They specifically work with SAP, with RFID sensing data. So for example, if you're using radio frequency identification, by that we mean those small wireless sensors that can be attached to items or pallets and use pretty much like barcodes, but remotely, you need to have this data flow into your central ERP system. So their software would do that. They would help to integrate barcoding and RFID sensing equipment with an ERP system. So all the data is fed into central database. One project that they did was a project for Dubai airport, because Dubai would use RFID tags to identify luggage, and they would integrate that luggage information with their ERP system, which was SAP. So that luggage information is also entered into a central database. Now, once you identify all those sources, you need to do some cleaning. Now, some sources have been in use for years, and because of that, they contain bad data. But bad data will mean missing or incorrect. I think missing data is a bit easier to deal with because you can just delete the record, but incorrect data is harder to deal with, where you're not sure whether those values are correct or not. And oftentimes this data is poorly documented. I mean, nobody has time to document things in detail. So that's why whenever you get a hold of data set, a lot of times you need to do your own research to figure out what the data set really contains. Now, fortunately, there are a lot of software applications or software tools for cleaning data. For example, some software applications, they allow you to deal with missing data. For example, um, one software application that I use is called SPSS. At least it used to be called SPSS. Now it's called IBM Modeler. And what they do, they help you estimate missing data based on the entire data set. Okay. So for example, let's say you have a data set about students, and one of the variables is their age. So based on the entire data set, it will guess or estimate the age of a particular student if it's missing from the data set, right? So they would use some sort of regression model to predict those values. Some software analyzes keys, like it finds like keys, former and primary keys. By the way, Microsoft Access does that. Sometimes it can guess that a particular item is a key, and many other software applications. For example, R will also guess whether a particular item is an index, right? But of course, when you're dealing with a source system, sometimes there is no way to eliminate human involvement. Sometimes you need to go and talk to a human subject expert, right? So for example, when you have an HR database, you may not be sure what some values mean. So you'll go to the HR department and you will ask them, so tell me what this, in your opinion, what this variable means, right? What's the formula that is used for calculating this variable? For example, well, maybe it's just me, but you know, a lot of procedures in our HR department, to me, it's like a mystery. And I'm not, because, you know, I'm like Sherlock Holmes. You know, Sherlock, if you read Conan Doyle, Sherlock Holmes used to say that your brain is like a storage room. I mean, it's like a closet, and you should not keep it cluttered, because if you put a lot of information, then you will not find something that you really need, right? So maybe it's just me, but I find like a lot of HR procedures to be very complicated. Like they have like all those like sick leave banks, and you think, I have no idea what that is. And I don't want to find out because I want to keep my head clean. I don't want to worry about things that do not seem to be that important, right? At least I don't have enough RAM to deal with all those issues at once, like giving my responsibilities with family and work and things like that. So sometimes, you know, I really like, sometimes when I run into a problem, I really need to talk to somebody from HR to explain to me all those things. Okay, so you do some cleaning. After that, you need to load it. Now, the entire process where you extract data from a source system, transform it, and then load it into a data mart or warehouse is called ETL. And ETL stands for extract, transform, and load. A lot of times ETL is performed automatically using SQL language, SQL queries. You can use SQL for manipulating data, but sometimes it's done manually. I mean, sometimes it's unavoidable to do some manual work. That reminds me of one experience that I've had. Just one second. When I was a college student, I did an internship at a company called Miratech. It was like a large Ukrainian software company. And they put us, somebody is joining us. They put us in different divisions. I was in the ERP consulting division. So I was supposed to become like an ERP consultant, something like that. But two of my friends, they were in their database division. They were dealing with data. And I found it funny. We were drinking coffee like during one of those work breaks. And one of them said, well, you know, this data transformation is such a big task. I mean, I've been working on it for a week, and I think I still need like a few weeks to complete the migration from one database to another. And the other guy says, well, I'm done with my migration. He said, what did you do? He said, well, I used SQL. I wrote a script. So it took me like a couple of days to copy everything. And he's like, really? You can do that? He was doing it manually. He was like manually copying data from one database, like one record at a time, and putting it into another database. Okay, but we'll see. You know, we have assignment 2 coming up, and most people do it like in an automated fashion. I'll show you, but some people do it manually. I'm actually surprised that they have the tenacity to do it manually. I guess they don't want to learn that tool, or they run into technical glitches, so they ended up doing it manually. So that's why I'm saying sometimes you don't, you know, sometimes there's no choice for you but to do things manually. Like if you don't have a tool, or if this tool is not working properly. Now, there's also commercial data integration that helps you like to automate some of those things. So it's not just, it's not like SQL based, it's not coding based, it's more like visual interface, a point and click type of software that helps you transform data from one source to another. When you do those transformations, we'll do those transformations like from Excel to Access and back and forth. So there are those wizards those tools that allow you to automatically transform data, right? So you answer some questions, you show which variables you're interested in, and it automatically transforms data from one source to another one. By the way, data is loaded into a warehouse during the so-called load window period. So it's not like real-time update. Again, the reason they don't do real-time update because it will slow down performance of the entire system, right? So basically they do this loading, that last part of ETL, during a certain window. Sometimes they do it at night so that they don't disrupt the entire organization, okay? By the way, speaking about loading window, you know, Google, as you can imagine, operates on a huge database. I mean, if you think about it, it does seem to be mind-blowing. Think about it. Google has a database of the entire World Wide Web somehow, right? Now think about how big that database is, okay? What's even more amazing to me is that not only this database is huge, you can query this database in a matter of seconds, right? If you send a request to a Google database, you'll get a response almost immediately, right? So it's amazing how they do those things. Nowadays, it's not very visible. In the old days, I'm talking about maybe 10 years ago, maybe 15 years ago, there was something called Google Dance. Have you heard this term, Google Dance? So Google Dance was the period of update of the entire Google's database, right? So basically, they had all those crawlers recrawling the entire World Wide Web or the World Wide Web that was visible to them and updating their database based on that new crawl, okay? And the reason you could see that Google Dance, because things change. For example, you search for Pizza Murray, and it gives you different results every time you search. You search it, and then you get like one result at the top, let's say Caesars. You search it like within 5 minutes, you get another result. So that's how you know that Google Dance is happening. They're updating their database, okay? And the reason I knew about that, because at that time I was working as a web developer, and eventually I got into search engine optimization, helping website owners optimize their websites so that they appear on the top of their Google's search results, right? So a lot of times clients would complain, they would say something like, well, what happened to my website? It's nowhere to be found. Sometimes it will completely disappear from Google search, right? And I would say, well, just wait a little bit, maybe they will update their database and things will normalize. But for some reason, I mean, for some people, that database update is a good news because their website will get a better ranking within Google's search database. Sometimes it will disappear, or sometimes it will lose its rank, right? So that was a problem for a lot of organizations who are making money from their website. So yeah, there are many architectures for storing data. There are many approaches. We'll talk about some of those architectures and approaches when it comes to organizing the data warehouse. Some organizations just do independent data marts. So what they mean separate databases for specific applications. By the way, there are some advantages to this approach. They're easy to create, and they meet local needs. You know what? They're good enough to support individual departments. I think that's the approach that Murray State is using. They're using separate databases to make sure that to lower cost, to make it easier to manage things, right? But at the same time, there are problems with that, with having individual databases for individual departments. First of all, there is no single version of the truth. We mentioned that, right? Different departments have different databases, and you're not sure which database actually gives you correct information. You have inconsistent data definitions and dimensions, so it's hard to run cross-departmental processes where it needs to rely on different data sources. And also, it can be expensive to maintain because, look, you're talking about separate databases. Sometimes those databases have different licenses. Oftentimes, you need to hire different people to maintain those databases. For example, I know a couple of people here at Murray State, like some staff members, whose job is to maintain a particular database, okay? Versus an integrated approach. Again, in my former organization, I think we had one single DBA, database administrator. We had one guy responsible, you know, I mentioned him, Steven. He was responsible for that entire centralized database. Here, I know one person who he was my former student. He runs a database for one of the research units at Murray State. I know another person, she is actually my neighbor. She runs a database related to some biological data here as well, right? So different people are responsible for different databases. It can be quite costly. So that's why, so independent data marts are still there. Many organizations are still using, but nowadays there's that push for creating standard centralized data warehouses, that huge storage spaces that store the entire set of organizational data. When it comes to organizing data warehouses, there are 2 or 3 main approaches. The reason I said 2, because the third one is a combination of these 2. The first one is called enterprise data warehouse, the so-called hub and spoke model. Now, that discussion will be very theoretical. I mean, I don't think I can illustrate some of those concepts right now, but we'll have a practical exposure to those concepts when we actually build databases in this class. And then you have a data mart bus, the architecture and term coined by somebody named Ralph Kimball. So that's his website. Up to this date, there's a lot of debate which architecture is better. I will ask you this question once we're done talking about those architectures. So I'll ask you, I will not settle this debate right now. I'll ask you like which architecture you think is better. So there's a disagreement nowadays, up to now, which architecture is better and more efficient. And then there's also federated. Federated means a life dictated by life itself. Usually it's some kind of compromise between these two, right? So now it was created without any central planning. So let's talk about the data warehouse, enterprise data warehouse approach. And I'm sorry, like a lot of those ideas, they're very theoretical and there's no way for me to quickly illustrate like what those things are. So let's just go through them quickly. So it starts with enterprise level analysis of data requirements. You see what are the data points or variables that are needed across the entire enterprise. And then based on those needs, you create a scalable infrastructure, meaning the kind of database infrastructure, data infrastructure that can easily expanded if the business, the organization changes. This architecture is developed in an iterative manner, subject area by subject area. So you can always add a subject area, you can remove, you can update the links. Data is stored in the third normal form. Again, we'll discuss in detail here what we mean by third normal form when we talk about databases. And then dependent data marts are created based on the data from the warehouse. By the way, dependent data marts can be either physical, meaning like a separate box, a separate server, or logical, like a subset, like a virtual subset of the entire database. But still, different departments may have different data marts, different databases, but because they're all derived from one central warehouse, they have single version of the truth. There may be some delay, like, it takes to update an independent data mart, but again, it will come from the same source, so all data will be the same. Dependent data marts often store data in a multidimensional star schema. So it's all about having tables where variables are stored and those tables are linked to each other. This data model is called star model, but I think it's a more common term for the data organization model is ERD, entity relationship diagramming method. So I'm sorry, I quickly went through that. I know it doesn't make much sense because it's a very kind of generic theoretical discussion. But I like this illustration. So this is how data is organized nowadays in most data warehouses. You have tables, separate tables. For example, here we are talking about a small data warehouse for a hospital. So some of those tables describe patient data. Some of those tables describe data of physicians or doctors. Each table has certain columns or attributes. And then all those tables are linked together. For example, to process an insurance claim, you need to know which time period during which the services were rendered, for which patient, who is the payer, and who is the physician. So let me check. Okay, Violet says she's late. That's fine. You don't need to apologize. So this is the essence of how data is organized in the data warehouse. Again, look, if there's a new entity, if you need to store, let's say something new comes on, let's say some kind of COVID requirement, right? A set of COVID requirements. You'll create a new table called COVID requirements, and you will link those requirements to, let's say, claims or something like that. So it's very scalable. It's organic, right? It looks like it's chaotic, but that's the benefit of having something that's not that rigid because it can be scaled. It can be updated if the needs of your organization change. Now, data mart bus, so that's an alternative way of organizing data. It's a bit more structured, okay? So what they do, they analyze the entire organization at the level of business processes. So orders, deliveries, customer calls, or billings. And then they build, they build data, they identify data points for each of the business processes. And then they're looking for overlaps in those data points, okay? So the entire data set, so this is like the analysis. You have those processes like issue purchase order or receive warehouse deliverables. And for those processes, you need the following data points or dimensions, as they call them. Date, product information, I don't know, store information, promotion information, customer information, employee information, right? So you do this analysis across business processes, and then you organize all those data points, and then individual business processes, they draw on those individual data points, right? So it's about like compressing data needs, like having an understanding of data needs across business processes and compressing them together by identifying a set of values or set of variables that are needed across different processes, okay? So although it's very theoretical, maybe I can ask you a practical question at this point. So which approach do you think is better and why? Would you rather organize your corporate data in accordance with the data mart bus architecture or data warehouse architecture? What would you say? Just give me any opinion. Which one? Why? Well, both of them have data in one place, right? I mean, that's the whole point of a warehouse. But which architecture is better? So why do you need to wait for data mart bus architecture type of warehouse? Okay, so you don't have a persuasive case. I mean, I agree with you, right? I mean, I agree with you that sometimes it's not about waiting for data. It takes more time to organize data like this, right? So any other thoughts or opinions? Go ahead. I'm sorry. So the other one looks like this. That's the architecture. So it's like organic, like branches on a tree, right? Well, this one is more like tabulated circuit type of format. So which one do you like better? Which one do you think is better? Why? Well, we're not in an art class, right? We're not talking about aesthetics. Like it looks, I mean, to me, this looks better because I've noticed like I have like a mind of an engineer, and when I see something like this, it drives me insane, right? When I like something that's very organized like this. So to me, this one looks more aesthetically more pleasing. It depends on the taste. But we're not in an art appreciation class. And but that's a good thought. I mean, it looks. Sometimes it's just a matter of aesthetics, right? Some people like, I don't know, Chevy because it looks right to them. Right? I asked some people, they just feel like Chevy, is right for them. For example, one car from aesthetical standpoint that I don't like is Dodge. I don't know what it is. It doesn't look right to me. Like the everything, the interior, the exterior. And I'm not saying it's a bad car, but just from an aesthetical standpoint, it's not my type of car. I think I like Ford. Like Ford looks right to me. I'm not sure. Definitely, I don't like Dodge. I don't like Chevy. Although Chevy is closer to me to like rather than dislike. Right? The other thing that I don't like Toyota interior. It doesn't look right to me. The interior and the design that I like is Honda. Everything looks right to me when it comes to Honda. Again, it's subjective impression, right? What about objective, like practical considerations? Any other thoughts? Okay, let's ask Brandon. He's a database expert. He's somewhere in Zoom. Brandon, what do you think? What are your thoughts?
For the bus versus.
Yeah. No thoughts? Well, you probably know that that star schema is a more popular way of organizing things, right? So there is a reason why it's more popular. Well, I'm sorry for taking so long to answer that. I just wanted to steer some kind of discussion. I'm not a big database person, so I don't want to like settle the debate, but to me, I think the difference is practical. You see, this is a highly rigid structure that you need to have for your data, right? You need to organize your data in a very rigid fashion, okay? Being very organized sounds good in theory. Unfortunately, it doesn't work in real life. It doesn't work when you're trying to be too organized, right? So, for example, if you create a very rigid schedule for yourself, like I will wake up at 8 a.m., right? I will drink coffee between 8 a.m. and 8:15. I will exercise between 8:15 and 8:30, right? At 8:35, I will boot up my computer. So if you create a schedule like that that is very rigid, what's going to happen? Inevitably, the schedule will be violated because things do not work like that. For example, sometimes when I have a meeting and I think, oh, I'm just going to switch on my computer and I have a meeting, in reality, it takes me like 1 hour to update my software or something like that, right? So if you are very rigid about planning your day, you'll be disappointed because your schedule will be violated, right? And then it just doesn't make sense. It's like waste of effort to create those rigid schedules, right? So personally, I don't create rigid schedules. It doesn't work for me. I just say like in the morning, I will try to work on this. That's my schedule, right? I don't plan like between 8:15. Maybe it's me, but I believe it doesn't work in real life, okay? I remember there was one real, like I like to plan my day. I remember when I lived in Abu Dhabi, I was like, um, I had like a free day or something, and I planned to do 3 things. I forgot what was the remaining 2 things, but the first thing was to go to a bank and do something there. So I said, okay, in the morning I have free time. I'll do A, B, and C. A was going to the bank. Now guess what? I went to the bank and I spent there the entire morning because the system was down. I kept waiting for the right person and things like that. So that kind of occurred to me like, why am I bothering planning things, right? I mean, it's not going to work anyway. So yeah, rigid planning, rigid structure sometimes doesn't work, right? Life is too complicated. As Mike Tyson used to say, every boxer has a plan until what? He had an interview and I forgot who was he fighting against, but they were saying, well, he has this plan against you if he will do this. So what do you think? And you know what Mike Tyson said? He said, well, every fighter has a plan until he gets punched in the head or something like that, right? So he said, well, then your plans have to be changed. So rigid, it doesn't work because organizations change, right? They have different units being added, different departments being added, new products are introduced. So you'll spend a lot of time trying to organize your data in that highly rigid fashion, and then the requirements will change and you have to reorganize it, and it becomes like a never-ending frustrating process, right? So this approach is more realistic, it's organic, right? Okay, we have data requirements for physicians, let's add the table. If we have COVID requirements, let's add a COVID table. Maybe it's not optimal in the sense that there will be some duplications in those 2 tables, so it's not like completely organized and efficient, right? At the same time, it's more natural like that, right? So you can add, you can remove, you can reorganize, you can reconnect. So it's not that it's better, it's just more realistic. It's a more agile way of organizing your data warehouse using that kind of star schema rather than highly tabulated format. Okay? But again, from my aesthetic preference, I like things to be tabulated. I feel like if you don't tabulate things, you don't have complete control over it. You don't have complete understanding of your data. But again, life is more complicated than any table. And then the last type of architecture that we'll mention, the so-called federated architecture. Federated architecture means created with no planning, created by life itself. Oftentimes, federated architecture happens due to mergers and acquisitions. 2 companies merge together, okay, and they don't want to disturb operations of either of the companies, so they allow them to use their separate databases, right? And usually they add some kind of patch to kind of connect them, like some kind of middleware that connects those databases, but those are separate data warehouses, separate databases, okay? Oftentimes they're hesitant to create a central database because they believe that it will disturb operations so much, the operations of one of those or both companies will stop, right? Sometimes it's like a cultural thing. They don't want to create a central database because they want separate organizations to preserve their unique cultures, so they operate in a different fashion, right? But what happens nowadays quite often is that when 2 companies merge, a lot of times they like to say that it's an equal partnership, but in reality, there's one dominant partner, and they will just migrate everybody from that less dominant company to a new platform, right? So they will quickly eliminate that federated architecture. I don't remember when it happened. In Houston, there was a big company called Compaq. It was a computing company. They were producing computers, bunch of peripheral equipment. Have you heard about this company, Compaq? Well, it was well known. It was like one of the main players in the computing industry. It's, similar to IBM, not as big as IBM, not successful, but it was a big player. So eventually HP, and you probably know HP, Hewlett Packard, they merged with Compaq. And I remember for the first couple of years, the name was something like Compaq HP or HP Compaq. It was like a double name. But within years, I mean, there was such a big cultural clash. And with HP being the dominant company, the biggest, the strongest company, they quickly swallowed compact. So nowadays, nobody even know what compact is, right? It's HP, right? But compact got digested. They completely swallowed them and they put them on the rails of HP. But for the first couple of years, they were trying to run two companies separate. There was a federated infrastructure, but eventually they gave up because it was too much of a problem, not having that lack of integration within the same company. So that's federated. You kind of keep things as they are. You introduce some patches. You don't have any central architecture, central idea. Okay, friends, so we're done with our business intelligence lecture. Let me quickly take attendance before we go. And I would like to remind you that on Thursday, we'll start working on individual assignment 2. And please attend this session because you'll get lost and you will end up doing things manually if you don't attend that lecture, okay? So please make sure you attend, so I'll explain to you how to source data quickly. Clifton?
Here.
Okay, Braden? Nathan? Devontae?
Here.
Thank you. Aaron? Jessica? Hope? Sean?
Here.
Harrison? Tristan? Here. Violet?
Here.
Mason? Here. Ahmed is here. Thank you. Okay, guys, you're free to go. I'll take attendance in my Zoom section. Thank you for coming today. Wesley?
Here.
Yes, Wesley today, he's here. Aaron Haney?
Here.
Thank you. Tucker is here. Shanice is here. I saw her. Jacob?
Here.
Jacob? Not here. Caitlin?
Did you not hear me?
Who was that? Jacob?
Jacob, yeah.
Okay, sorry about that. Caitlin, not here. Jason Reynolds?
Here.
Thank you. Brandon, here. Casey?
Here.
All right. Thank you very much. Thank you for joining us today in Zoom. Also, make sure you attend our Zoom session on Thursday because I will also demonstrate to you what to do with assignment 2. If you don't attend it, sorry for being adopting a threatening position, but you will have a hard time.